Hello. Today we're going to look at solve a system of equations using any method, specifically word problems. To this point, you've been solving equations using just the algebraic method, calculations only. You've solved systems of equations using substitution and elimination. Today we're going to put that skill to work, or those skills to work, within the context of real-world situations. So I'm not going to be solving them for you today. I'm just simply going to show you how to set them up. Our first question or statement or story goes as follows. Scouting troops in Clay County are putting on a crab feed to raise money for camp. They offer a complete crab dinner as well as a vegetarian option. One troop member sold tickets for 34 crab meals and 12 vegetarian meals with a total receipts of $1,296. Another sold tickets for 22 crab meals and 34 vegetarian meals, bringing in a total of $1,442. How much do the two types of tickets cost? Well, think about this. First of all, in the question, it's pretty much giving you how to set up the equations. If you want to know how much the tickets cost, then you have to consider what tickets are they talking about. Well, we have an idea here when they tell us they offer a complete crab dinner as well as a vegetarian option. So that's one clue. The other clue is that they tell you what the troop members did. One troop member sold 34 crab meals and 12 vegetarian options, or vegetarian meals. So we need basically a variable for the crab meals, and we need a variable for the vegetarian options. Now you can name them X and Y, you can name them C and V. What I'm going to do is I'm just going to lay this out as one troop member, and I'm going to write an equation for what he did. So he did 34 crab meals, and he had 12 vegetarian meals that he sold, and he sold those for a total of $1,296. Well, that's all well and good, but that doesn't help me solve for either. Then we have to think about, if that doesn't help me solve, there must be another equation going on somewhere, and there is. Now, here's your other clue. Another. So you had one troop member right here, and you had another troop member, so that must be the other equation. And what did they do? They sold 22 crab meals, and they sold another 34 vegetarian meals. And they sold that for $1,442. Now, this is elimination, obviously, because these are written in standard form. And what you can do is decide which variable you're going to eliminate. And then what I would suggest, since they don't have the same coefficient, one easy way is to multiply the first equation by whichever one you're going to eliminate. In other words, if I was going to eliminate the C's, then I can multiply this entire first equation by negative 22C, and then multiply the second equation by positive 34. And that would go ahead and set up the elimination for the C term. And I think I just said multiply by 22C. I just meant multiply by negative 22. Here, if you're going to eliminate the V's, then you could multiply the top by negative 34 for every term, and then multiply the bottom by positive 12 every term, and that will help you eliminate the V's. whichever one you choose. Here's another situation we could look at. A couple of friends decide to race each other. Dana can run 4 meters per second, whereas Kevin can run 6 meters per second. Because she is slower, Dana also gets a head start of 30 meters. Shortly after they start running, Kevin will catch up to Dana. How long will that take? How far will Kevin have to run? So when you're looking at something like this, understand that in every system of equations, there's always two things going on. There's either going to be two people doing something, there's going to be something happen one day and then another day. It's going to be something was sold or something was bought. So there's always two situations going on. In this situation, we have two runners. One is Dana and the other is Kevin. And we're told some information about Dana and Kevin. What we're told is that Dana can run 4 meters per second. So we know if she's running 4 meters per second, that that's really talking about slope. So we could almost visualize this being in slope-intercept form. She can run 4 meters per second, and she gets a 30-meter head start. So how many ever seconds she runs, and I just use n arbitrary, you could use s or x or whichever you choose. How many ever seconds she runs, that's going to determine the total time that she runs. So we could say y is equal to 4 meters per second plus the 30-meter head start. So really, this is talking about how many total meters she would run, not how quickly she would run it. Then Kevin, we're told, runs 6 meters per second. So what we're told at this point is, okay, I want you to figure out how long will it take, and then how far Kevin would have to run. And what we've learned is that when we have y equals, so when we're slope-intercept form and slope-intercept form, we can put them equal to each other and solve. So that's another type of word problem that you might see. So I've showed you two types of word problems. One was elimination and one substitution. So I really wasn't trying to show you how to solve them because you've been doing that. What I was really trying to show you is how to set them up. If you have questions during class and you need to talk to me about it, please feel free to do so. Goodbye.